We'll begin with the linear algebra and calling out the answers to the even problems. First of all, on page 83, number 4, you had to show that these two matrices are inverses of each other. So you do that by multiplying them together, and it will give you the 3 by 3 identity matrix, which is the matrix with ones on the main diagonal and zeros everywhere else. Number 8, someone had a question about, and the directions there were to find the inverse of the matrix if it exists. For a 2 by 2 matrix, there is a formula for finding the inverse that I went over in the video, but prior to that, well, part of that formula is finding the difference of the cross product. If the matrix is A, B, C, D, you find A times D minus B times C. I said cross product. I don't know why I said that. I meant the difference of the products of the diagonals. So -1 times -3, subtract 1 times 3. If that is a result of 0, then the matrix has no inverse. So that's what you had to do for number 8. Or if you just jump into the formula that you were given to find the inverse of a 2 by 2, where you switch the terms on the main diagonal and change signs on the other diagonal, you're multiplying that by 1 over this difference. Well, that's undefined. So you can't multiply undefined by something. Again, it has no inverse. Number 12 on that page, the answer, oh dear. Okay, let me find it. Okay, there was no number 12. Number 10. There you had to find the inverse, so you're converting the given matrix to the identity matrix using row operations, and the inverse should be the 3 by 3 matrix whose top row is -13, 6, 4. The second row is 12, -5, I can't read my writing, -3, okay? And then bottom row, -5, 2, 1. Then there's a question on 13. Can anyone tell me specifically what the question is? Or you just didn't get the right answer? Is that who?
I get the right answer, and I'm not sure where I went wrong.
Okay. It is extremely difficult to find a mistake in one of these. I can't find a mistake in mine. If I don't get the right answer, I just start over because it's just really difficult. So as yucky as that sounds, that's what you need to do if you make a mistake. So let's just go through it and see if we can find your mistake. Okay, my mouse is going to start playing tricks on me again. Okay, so the deal is we want to get ones on the main diagonal, zeros everywhere else. Start with column 1 and convert that top number to a 1. It is already a 1, so that step is complete. My next step is to change the 3 to a 0. So I'm going to take row 2, come on mouse, row 2, and subtract 3 times row 1. So my row 2 is 3, 1, 0, 0, 1, 0. Multiplying row 1 by negative 3, my new row 1 here, negative 3, negative 3, negative 6, negative 3, 0, 0. So that will give me my new row 2. My next step is to change the negative 2 to a 0. So I'm going to take row 3 and add 2 times row 1. So row 3 and 2 times row 1. So that will give me my new row 3. Okay?
Yeah, I just noticed I accidentally, for some reason, I think I saw the negative in front of 2 because I had the rows the other way, and I think I forgot that I was adding it, and I subtracted the 4 and the 3.
Okay.
Instead of 7, I got a 1.
Okay. And see, that'll throw everything off after that. Anyone else need to see that problem? Okay. So my next step is to target that negative 2. I move to column 2 and I need to get my 1 in place. So I'm going to divide by negative 2. And that will give me my new second row. 0 divided by negative 2, negative 2 divided by negative 2, negative 6 divided by negative 2, negative 3 divided by negative 2, 1 divided by negative 2, and 0 divided by negative 2. So now we're in fraction world. My next step is to change this 1 to a 0. So I want to take row 1 and subtract row 2. So I copy over row 1. And what I do is I multiply my row by negative 1 and then add. That way my signs are in place. So 0 times negative 1, 1 times negative 1, 3 times negative 1. Just go through and change all of those signs. 1, 0, negative 1. 1 is 2 halves, so that will be negative 1 half, 1 half, 0. And now that's my new top row. I need to change the 2 to a 0, so I'm going to take row 3 and subtract row 2. Up to row 2. 2 times 1. Yep. So, whoops. So my row 3 is 0, 2, 7, 2, 0, 1. And I'm going to multiply my row 1 by negative 2. You know what? That's going to give me my old row 2 back. But, so now I have 0, 0, 1, negative 1, 1, 1. 0, 0, 1, negative 1, 1, 1. first two columns are complete. Now I move to column 3. And in column 3, I need to get my 1 in place. It is, so that step is done. So I can go ahead and begin to write my matrix with my new and final row 3. And my last two steps will be to change the numbers above it to zeros. Starting with a -1, I want to change that to a 0. So I take row 1 and add my row 3. So row 1 and add row 3. And that will give me my new row 1. -1/2 and -2/2. 1/2 and 1. 0 and 1. And then my last step is to change the 3 to a 0. So I want to take row 2 and subtract 3 row 1. Oh, thank you. I need to work with row 3. So I take row 2 and subtract 3 row 3. Okay. Who grunted first? Sound, was it? I don't know. I knew it was male. And I knew, ooh, I made a mistake. And then Ethan started talking about it. But somebody made a noise first. So tell me who that was. And I'll keep. Okay. So where is my road? Where am I? Where am I? I'm trying to write row 3. Okay. And then multiply row 3 by -3. So 3, 3, -3, -3. And then you get 0, 1, 0. 3 is 6/2, so that's 9/2. -3, -7/2, and -3. And I'll scream if it's wrong. I have screamed many times. It's just tedious, and you have to have your mind on the game, because if you make one little mistake, you don't know it until you get to the end. Let me pause for a moment to find the next part. Okay, let's start with 31B. And we are asked to find A transpose inverse, where A inverse is given as 2, 5, -7, 6. Well, in the properties of inverses and transposes, which is in your book on page 78, but I also had it in the video, property number 4 says that A transpose inverse is the same as A inverse transpose. So I'm trying to find A transpose inverse, or the inverse of the transpose of the matrix. I am trying to find this, so I can do it by doing this. Find the transpose of this matrix. To find the transpose, the row becomes a column, and like that. Done. That's what I'm trying to find right there. Okay, so for part D, D is asking for 2A inverse. And again, if you go back to the properties, property number 3 says that a scalar times a matrix inverse, which is what we're trying to find, is equal to 1 over that scalar times the inverse of the matrix, as long as the scalar is not 0. Did I have that in your, do you print out the notes? Okay, so that one should have been there in the properties. So to find this, I want 1/2 times A inverse. So that is 1 5/2, -7/2, and 3. Okay? Number 52, wait, was that 38? No, that was 31. So 38. Show that the matrix is invertible and find its inverse. What do I need to do to show that the matrix has an inverse? Sine squared minus negative cosine squared. I need to show that the difference of the product of the diagonals is not 0. We did that in this problem. So you multiply the diagonals together, you subtract them, and as long as you don't get 0, the matrix has an inverse, which means it's invertible. So back to 38, as Murphy said, we're going to multiply sine of theta by sine of theta to get sine squared of theta. And from that, we're going to subtract cosine of theta times negative cosine of theta. So that gives you sine squared of theta and that's the fundamental identity. So it's not 0, so it has an inverse. How do we find the inverse? The formula is 1 over that number that we just got times the switcheroo matrix. That's where you reverse the terms on the main diagonal, which isn't going to look like you did anything because they're the same, and you change signs on the other diagonal, and then you simply multiply the scalar by that matrix. So the inverse is the matrix sine theta negative cosine theta, cosine theta, sine theta. No, it just turned off. That's the inverse. Okay? Go ahead. Helen is illustrating number. Oh, it's not aligned? Okay, pause the screen and we'll align it real quick. So number 52, we had to show that a squared minus 2 times a plus 5 times I equals 0, where I is the identity matrix of order 2. So Helen is doing the a squared part, multiplying a times a. Okay, let's stop right there. Do y'all agree with that first element? Or should that be 1 plus negative 4? Okay. Okay, so negative 3, 4, negative 9, negative 3. Is that okay? Because I haven't gone through the rest of it. How about erase that and fix it? It's hard to correct those. Negative 4. How about the top row, second column, where you're multiplying negative 2, 1. You're multiplying the bottom row by the second column. Yes. Okay. My question is it in the right place? Yes, okay, negative 4 plus 1, okay. So if it's negative 4 plus 1, should that be a negative 3? Okay, okay. So, we okay on that part? Okay, thank you, Helen. Now, who would like to come up and take that matrix and then subtract 2a from it? Okay, Alexis. Very good. Excellent. Then we have one more step. Murphy's going to do the last step of that one. Yes, it is. Very good. Okay, so you're just evaluating that equation using matrix A. Multiply A by itself. From that, subtract 2 times the matrix A. And to that, add 5 times the 2 by 2 identity. And that shows you that you do get 0. Number 9 on page 95. Here we are given three matrices, A, B, and C, and we want to find an elementary matrix E such that E times A equals B. So I'm involving B and A. Here's B. And here's matrix A. So I want to find some matrix that I can multiply matrix B by to get A, because it said to find an elementary matrix E such that E times B equals, oh, I'm sorry, E times A equals B. So here is A, and I'm comparing that to matrix B, and I notice that row 1 is row 3, row 2 is row 2, and row 3 is row 1. So row 3 and row 1 have been reversed. This is driving me crazy. Row 3 was changed to row 1. So I take the identity matrix of order 3 and I change row 3 with row 1. So this row 1 is now going to be 0, 0, 1. Row 2 stays how it was, and row 3 is 1, 0, 0. So that is matrix E. That is my matrix E, such that if I multiply it by matrix A, I get matrix B. Now, how would you check that? You would do it. You would multiply this matrix by matrix A and show that it equals matrix B. The answer to number, well, hang on, where's my assignment list? Pause. I want to convert matrix A into the identity matrix. each step I record what I do and do the same thing to the identity matrix. So in other words, step 1, I'm going to multiply my top row by 1/4 or divide it by 4. However you want to look at that means the same thing. So 1/4 of row 1 becomes 1 negative 1/4. Row 2 is the same. So that means my E1, I'm taking the 2 by 2 identity and I want to do the same thing to that I just did to, yes, do I have a mistake?
No, I was just wondering why you couldn't subtract row 2 from
That's
row
what
1,
I did.
because that's what I did.
Subtract row 2 from row 1?
Row 1 minus row 2.
To make the first row.
Okay, well let's see, did you get to an answer?
I'm not sure. I had a question mark by it.
I got some.
And did you get the answer they had in the back of the book?
Yep.
Okay, then it works. Okay, good job. I just always get my ones by multiplying, but you can do it by subtracting or adding. Or so my E1 then, what did you do with to make your E1? I guess your E1 is going to be different than my E1, isn't it?
Yeah.
My E1 is going to be 1/4, 0, 0, 1.
So just 1 0.
Okay. So now my second step is to change the 3 to a 0. So I need to take row 2 and subtract 3 row 1. So this is when I pull out a piece of scratch paper to do this on because it gets so cluttered otherwise. But over here I'll take my row 2 and I'm going to multiply row 1 by -3. So -3 times 1 and -3 times -1/4. And that gives me 0 and -1/4 for my new bottom row. So my E2, I have to do the same thing to the original identity matrix that I just did to my matrix. So I take row 2 and I subtract 3 times row 1. In other words, multiply row 1 by -3 and add. So that gives me -3, 1 for my bottom row. Are we okay so far? Harrison?
Honestly, no balance wise, do you do it to the first matrix again for E2?
You always go back to the original identity matrix to get your E matrices. So now my next step is to make this number a 1. And I would do it multiplying by -4. I would say -4 times row 2. So that gives me the matrix. Top row, nothing happens to. And the bottom row is 0, 1. So that makes matrix E. Again, going back to the 2 by 2 identity, do the same thing to that we just did to this matrix. So multiply the bottom row by -4. The top row stays the same, and the bottom row is now 0, -4. So that's my E3. Then my last step is to change the -1/4 to a 0. So I would have to take row 1 and add 1/4 of row 2. So row 1, multiply row 2 by 1/4, and that will give me the 1, 0. So 1, 0, 0, 1, which makes my E4 I have to take the 2 by 2 identity and do the same thing to it. So I want to take row 1 and add 1/4 row 2. So that gives me 1, 1/4. So I have 1, 1/4, 0, 1. So the factors of matrix A would be E4, E3, E2, E1.